Okay, so this is number 5 on the practice test where it says aluminum metal is oxidized to Al plus 3 by hydrogen peroxide, H2O2, in the presence of a strong acid. And the reason they tell you it's a strong acid is because there's H pluses present. Answer the following. Table of standard reduction potentials may be useful. And so since it says aluminum metal is oxidized, that one is going to be my anode reaction, because an-ox. And then this is going to be my reduction half reaction, which is my red cat. And so since aluminum is oxidized, that means hydrogen peroxide must be reduced. So if I look on the standard reduction potentials sheet, and then I find hydrogen peroxide, I can find the cathode half reaction, and H2O2 undergoes reduction in a acidic solution by having 2 H pluses plus 2 electrons go to 2 H2O. And so you can write down the standard reduction potential, but you don't need the number because they don't ask you to calculate anything. They just want to know the equation. Then the anode half reaction would be aluminum being oxidized to Al plus 3. And so it would be the reverse of this reaction, right? Because this reaction right here is written as reduction, and I want oxidation. And so aluminum would go to aluminum plus 3 electrons. And if you can't see these super well on here, you'll have to get your own chart, but you can see that there's my half reaction for H2O2, and then here's my half reaction for aluminum. And notice how I reverse that one because this is oxidation. And this is written, they're all written as reduction, as we know, because it's called the reduction potential table, but I reverse it because it's oxidation. Okay, so those are my two half reactions, and now it wants the overall balanced reaction, so you need to remember some things about balancing chemical reactions, redox reactions, and that before you can combine these two reactions together, you have to have the electrons cancel out. And since there's 2 here and 3 here, I'm going to take this equation and multiply this one by 3, and I'm going to take this equation and I'm going to multiply it by 2, because then I'll end up with 6 electrons here and 6 electrons here, and they'll cancel. So I'm going to rewrite those, my reduction half reaction here, my oxidation reaction half right below it. So that would be 3 H2O2 plus 3 times 2 or 6 H plus 3 times 2 or 6 E minuses, or 3 times 2, 6 H2Os. And then on the bottom reaction, 2 ALs, and then an arrow, and then 2 Al positive 3 plus 2 times 3, or 6 electrons. So now you can see that my 6 electrons will cancel with my 6 electrons. And then I can just take a look on here and see if there's anything else on this side that would cancel with anything else on this side. Did I do okay on the multiplication here? People that are watching me live, did I do my math okay there? Is that all right? Okay, so then I'd write the whole reaction right here, and I'd end up with 3 H2O2 plus 6 H plus 2 aluminums, arrow, and then 6 H2O plus 2 Al positive 3. And that would be my question number 5.